Hello, my name is Khoi Pham, and this is my final video project for Mr. Lewis's AP Statistics class. And this video will be about two sample t-intervals. Okay, first I'm going to talk about the difference between the normal model and the t-model. The normal model, the standard deviation of the population is known, and therefore the 68, 95, 99.7 rule will apply. But with the t-model, the standard deviation of the population is not known, and the degrees of freedom changes the variability, so therefore the 68, 95, 99.7 rule doesn't apply to it. I am now going to sketch an example of the difference between a normal model and a t-model with 2 degrees of freedom. The normal model is drawn in red while the t-model is drawn in blue. As you can see, the normal model has its data more spread out, while the t-model with only 2 degrees of freedom has most of its data put into the center of the distribution, and as you can see, its tails are flatter. Now, what a two-sample t-interval is used for is to find a confidence interval where the true difference between two means might lie. The confidence interval may become smaller or bigger due to the level you use, and confidence interval can also be used to show if there is any difference at all between the two means. Now, the assumptions and conditions of a two-sample t-interval besides the independence assumption are the randomization condition, which states that data must be collected with suitable randomization, the 10% condition that states that samples must be less than 10% of the population being studied, the nearly normal condition states that both groups being studied and compared must have a nearly normal distribution, and the independent groups assumption states that both groups that are being compared must be independent of one another. Now I'm going to explain exactly how to do a two-sample t-interval. The equation for a two-sample t-interval is y bar of 1 minus y bar of 2, which is the mean of group 1 minus the mean of group 2, plus or minus t star times the standard error of y bar 1 minus y bar 2. The standard error of y bar 1 minus y bar 2 is the square root of the standard deviation of group 1 over its sample size squared plus the standard deviation of group 2 squared over its sample size. And the t star value is also known as the critical value. The equation to find a critical value of a two-sample t-interval is very complicated. So usually you would just find the critical value by using the two-sample t-interval function on the calculator. But we can also use an approximation if you need to, which is what I'm going to use for the example I will do soon. So to find a critical value approximation for a two-sample t-interval, you must round the sample down if it is not an integer. Then you must press distribution. Then go to number 4, which is inv-t. Then you enter the confidence at level, and you also have to add the tails divided by 2. So for example, if you want to use a confidence interval of 95, you have to use 0.975 when you enter it into the calculator. Then you must enter a comma. Then you enter your degrees of freedom, which is the sample size that you rounded down minus 1. So for example, if you wanted to find the critical value for a problem that involved needing a 90% confidence interval and it had a sample size of 10, you would do inv-t 0.95 comma 9, close the parentheses, and then you would press enter, and then you would get a critical value of 1.833. So for an example, let's say that you want to compare how many fruits an orange tree produces compared to how many fruits an apple tree produces. So let's say that in a field, a sample of orange trees has a mean of 30 fruits in a tree, and the apples have 20 fruits in a tree. And let's just use the critical value we just approximated. And let's just say they both have a sample size of 10. The standard deviation for the oranges is 7, and the standard deviation of the apples is 5. You would then get a confidence interval of 7.99 to 12.01. You would then conclude that I am 90% confident that the true mean of fruit that orange trees produces is between 7.99 and 12.01 more than apple trees. Now I'm going to explain how to do a two-sample t-interval on a calculator with a given set of data. First, you would enter all data into list 1 and list 2. Then you would check the normality of both data on StatPlot. Then you would go to Stats, then the Test menu. Then you would choose 0, which is the two-sample t-interval function. Then you would select Input Data, and then you would select the sea level. You would say no to pooling, and then you would press Calculate. Now I'm going to explain how to do a two-sample t-interval on a calculator without a given set of data. First you would go to the Stats button and then go to the Test menu. Then you would choose 0, which is the two-sample t-interval function. Then you would choose Input Stats and enter both samples' means, standard deviations, and sample sizes. Then you would choose the confidence level. Then you would say no to pooling, and then you would press Calculate. And that's all I have on two sample t intervals today. Toodaloo!